So with the very brief notes I'm going to give you about density, first of all, I'm just going to define it. I would define it as how tightly packed particles are. This isn't a textbook definition, this is just me and my own words here. If you've ever heard the term population density before, that means how many people are in a certain area. So New York City would have a high population density, a lot of people in a small area. The state of Montana would probably have a low population density. Heck, where I'm from, you know where I grew up? Charlie, I grew up on Rotzenberg Road. That's when you know you're out in the middle of nowhere. They name it after whichever family first built a house on that road. My block was 4.5 miles around. Low population density out in Muskegon, Wisconsin, out in the middle of nowhere. First time I took my wife to meet the parents, she got freaked out of, why are we driving out in the middle of nowhere? This is scary. This is where bad things, this is where people take other people to do bad things. Like, no, this is just where I grew up. Very low population density where I'm from. High population density in cities. Density, when we talk about different materials, is how close together the particles are. Something that's very dense means everything is packed in close together. Something that's not very dense, spread out. Now, in this class, yep, we have a lot of math. Here's your density equation. Density equals mass divided by volume. Which hopefully makes sense to us because the lab that we are doing, the density determination lab, last class you took mass measurements and volume measurements. It's going to be really tough, ladies and gentlemen, but your next 2 pages is taking those 2 numbers and dividing them. Nothing more than that, really. However, this could be for the lab. In any equation where we give you more than one variable, we expect you to be able to solve for those variables. For example, density is a known value for a lot of things. We know what the density is of an object. So we might not always ask you to solve for density. We might ask you to solve for mass. We might ask you to solve for volume. The math department would refer to this as isolating the variable. If I wanted to solve for mass, I'd have to multiply both sides by volume to get mass by itself. If I wanted to solve for volume, I'd first have to multiply both sides by volume and then divide by density. Some of you are great at that algebraic manipulation. Some of you prefer kind of a shortcut way to remember it. And that's this little triangle right here. Quite frankly, I have students in AP chemistry that will still use triangles for equations like this. How this triangle works. Whatever I want to solve for, I put my hand over it, it tells me how to solve for it. If I put my hand over D because I want to solve for density, it's mass over volume. If I want to solve for mass, it's density times volume. If I want to solve for volume, it's mass over density. Next thing to bring up. Really, we could use any sort of unit for our final answer to express density. As long as we had a mass and a volume, we could divide any mass and volume. There you go. The most common units of density are grams per milliliter or grams per centimeter cubed. If you don't remember from last week, these 2 units are the exact same thing because 1 milliliter is 1 centimeter cubed. Typically, we use grams per milliliter if it was a milliliter measurement, so volume from a liquid water displacement type thing. We use centimeters cubed if it was more of a length times width times height measurement. Very last thing to bring up. Hopefully your hand is not too sore. One of the things I hope you see throughout the course of this year is with all the different types of measurements that we bring up and talk about throughout the year, at the end of the day, somebody had to come up with what does 1 degree Celsius mean? What is 1 milliliter? I mean, these measurements weren't around since the beginning of time. It's not on, and on the 8th day, God made the metric system and told Adam and Eve, this is how you will now measure forever and ever. No, at some point, people just decided, hey, let's make a unit of measure for distance. Let's make one for volume, whatever it might be. Water is the basis of almost our entire measuring system. The density of water, 1.0 grams per milliliter. Recall when you did the lab last class and you did water displacement. A lot of things, when you put them in the water, they sink and the water level rose. What does that tell you about the density of those objects when they sunk in water? Is their density less than or more than 1? So whatever we kind of say the answer. Come on, we can do it. If something sinks in water, is it greater than or less than a density of 1? It's greater than. It has more mass in the same amount of volume. It's more packed in tight. And if things are packed in tight, they're dense. Although you've had an object that did not sink in water last time, floated in water instead. That should give you an idea of what its numerical value should have been instead. Now,